Hello, welcome to today's lesson, which is on law of cosines. Before we get into what law of cosines can do for us and how it does it, let's review when we can use law of sines and also preview when we can use law of cosines. In order to use law of sines, as we learned in the last video, we had to be given certain information about a triangle. One set of information we could have been given would have been two angles of the triangle and a side not between those angles. Another way we could have been given information about a triangle where we could have used law of sines would have been to have been given two angle measures and then a side in between them, or the side in between them. And also, another situation where law of sines can be applied is a side-side angle situation. And that gets to be a little hairy, but if you have two sides given to you and then an angle not in between them, you can apply law of sines to that as well. Law of cosines, there are a couple different situations we can use to apply law of cosines. One is SAS, so you'd have a side, another side, and then the angle in between them. And finally, side, 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 which is pretty straightforward. If you know the length of each side, even if you don't know any of the angles, you can figure the angles out using law of cosines. So before we talk about how law of cosines is different than law of sines, let's first review how they're similar. For one thing, just like law of sines, the law of cosines can be used to find missing pieces of a triangle, whether it's a side length or an angle measure. Also, just like law of sines, the law of cosines will work with all triangles, not just right triangles. The formula for the law of cosines can be written, you'll often see it written three different ways, but if you understand how to write it just once, you can generalize the other ways of writing it yourself. Now I'm going to go through all three ways, and your book has all three ways, but I'd like you to also understand where those other two ways came from. But the formula itself starts out looking exactly like Pythagorean theorem. Now, Pythagorean theorem only works with right triangles, so we need to adjust Pythagorean theorem for the fact that we're not always going to be dealing with right triangles, and over time it was discovered that adjustment looks something like that. 2ab cosine of angle C. Whatever you have for side lengths, you will repeat after the two. And then cosine of what, you might ask at the end? Well, whatever side you started out with, you will end with the cosine of that angle. It really comes full circle. Now, if I wanted to write this another way, if I wanted to say isolate side A in it, I'd start out with kind of a Pythagorean theorem looking thing. I know in Pythagorean theorem, the c squared gets isolated because that's the longest side. Here there's no guarantee that that's true. And you tack on an adjustment. Since we have b and c for our side lengths here, we'll have b and c immediately after the two. And since we start with side A in the beginning of the formula, we will end with angle A at the end. Writing this a third way, you can probably see where this is going. If you isolate the b squared term, you start out with a Pythagorean theorem looking thing, and then your adjustment will be a minus 2. After the 2, you have a and c, cosine of b, because you started out with isolating the side b squared. So let's look at a couple examples using this law of cosines. All right, in this particular problem, we need to find the side of length A. They were nice enough to put an X there for us. I guess I would be just as happy putting an A there. Using law of... What?
Testing, 1, 2.
Well, I hope that doesn't go on for long. I'm going to put a little side A there instead, because that's going to fit better with the formula. And honestly, we can just plug in. We know this, we're given that, that, and that. So we should be able to just plug everything in, substitute everything in, and get an answer. B squared in this case is 12.6 squared. C squared in this case is 10.8 squared. 2BC is 2 times 12.6 for B times 10.8 for C times cosine of angle A, which is 62 degrees. For 12.6 squared plus 10.8 squared, I get 275.4. So that's that much of it. Now I'm going to multiply all this garbage together and write that number down after the minus sign. And rounding it off, I get about 30.270. So if I subtract these two things, I get 245.13, which... Great. Which doesn't tell me how long A is, it tells me how long A squared is. To get A, I need to get rid of the second power, and to get rid of the second power, I'll take the square root of both sides. Now I'm going to round this thing off to the nearest tenth, which gives me about 15.7. Which is kind of in line with the other two sides. A side of 10.8, a side of 12.6, and apparently a side of 15.7. Seems, I guess, fairly reasonable given the information in the problem. This is an SSS situation. We're given all three sides. I guess it's worth noting that the last problem was an SAS problem. So these are the two cases where law of cosines will work. To get the measure of angle Q, I'm going to need angle Q in my formula. So that means I'm going to want to end with cosine of Q. And if I end with cosine of Q, that means I need to start the formula with side Q. So the way this is going to work is side Q squared is going to equal, I'm going to start out as a Pythagorean problem, side Y squared plus side Z squared. And then I'm going to deal with the adjustment term. It's minus 2, and then I use these sides over again, Y and Z, times the cosine of whatever angle is the same letter as the side I started with. I started with Q, I'm going to end with angle Q, which is good because angle Q is what I want to figure out to answer the question. So from here we start substituting in what we know. Q squared is 10 squared is 100. Y squared is 12 squared, which is 144. Z squared is 11 squared, which is 121. 2 times Y times Z is going to be 2 times 12 times 11. The cosine of Q, I don't know. I don't have anything to sub in for Q, so I will just leave it blank for now, or we'll leave it as a variable. Simplify what we can. 144 and 121 is 265. 2 times 12 times 11 is 264. And then we have a cosine of Q after that. And here is where people make mistakes very often. Because they will make their next step, and maybe you're looking at it right now, you're maybe thinking, ooh, I can take 265 minus 264. Not so fast. You can't. The 265 doesn't have anything attached to it. The 264 does. It's a term that has cosine q attached to it. We can't combine a number with a variable term, you know? So just like how if you had 265 minus 264x, you can't combine those. You'd have to leave that. That's simplified. Same thing here. We have 265 minus a variable term. All right. I know I'm harping about that, but I've just seen so many people screw that up over the years. I want to make a big point to hopefully have you avoid their mistakes. So then what do we do instead? We can subtract this 265 from both sides and just get rid of that term. It'll combine nicely on the other side with the 100. You get a negative 165 then on the left-hand side is negative 264 cosine q on the right side. From here, I can't isolate the q quite yet, but I can isolate the cosine q. I'm going to do that by dividing away the 264. The negative 264. I'm going to divide away that constant so I can get closer to isolating the variable. If I do that, my equation now reads cosine q equals this fraction. Now we have a negative over a negative, so that ends up being a positive. I'm going to therefore ignore those signs. I'm just going to call this 165 over 264. I still don't have the q isolated. I know what the cosine of q is, but I don't know what q is. So I need to kind of like quote unquote undo the cosine function. And if you remember from earlier in this unit, the thing that undoes cosine is inverse cosine. So this is a good calculator problem. I am going to take the inverse cosine of this fraction. By taking the inverse cosine of the fraction, I will have isolated q in the equation. I am getting about 51.3 degrees on my calculator when I do this. So to review, there's a time to use law of sines, and there's a time to use law of cosines, and it all depends on the information that you are given in the problem.